Jai Gurudev. Good morning, student. Today we'll start internal energy. It is represented by E or U. The sum of the total of all the energies of a system is called internal energy. The sum of the energy, for example, potential energy, kinetic energy, nuclear energy, electronic energy, rotational energy plus dot 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 dot. So this kind of energies add together gives you the internal energy. Now, one point student will remember that something which is on the system should be positive, by the system is negative. So, in chemistry, you remember the on the system is positive, by the system is negative. Now, we will start the first law of thermodynamics, which tells that the energy can neither be created nor be destroyed. It can transform from one form to another. A mathematical formulation of first law of thermodynamics. Let us consider that this one having energy U1, container having energy U1, and we do giving Q amount of heat to that one, so its internal energy changes to U1 plus Q. If we do W amount of work to that one, its internal energy changes U1 plus Q plus W. So this final stage of internal energy considered as U2. Now if we do U2 minus U1, which is del U, which will be equal to your U1 plus Q plus W minus U1. U1 goes. So therefore del U equal to Q plus W. This is the first law of thermodynamics. Formulation for the first law of thermodynamics. Now Q equal to U equal to Q plus W. If work is done on the system, that will be plus Q. Work is done by the system, that will be minus Q. Work is on the system, then it will be plus W. Work by the system is minus W. So now we have to start work and derivation of for the work you have to do. Work, as you know, work is nothing but force into displacement. So P into A into dl. P into A. Why P into A? We know force by area equal to pressure. Force equal to pressure into area. So pressure into area we have written dl is the distance covered. So if it is the V1 is the pressure, V2 is this pressure. If your external pressure, this is your internal pressure. If external pressure is greater than internal pressure, the piston will come downward. So this is the length or dl, that is this area is shrinks. Now this is its area of cross section A. A into dl, that much volume it shrinks. Now work done equal to P into del V. Why this volume? Because A into dl is nothing but P into del V. Now here one thing student you consider, that if I do that final volume minus initial volume, this is the final volume V2, this is initial volume V1, that terms comes to be negative. And if this term is negative, work become negative. That is why by sign convention work is always positive, so we have to put the sign negative. Negative into negative become positive. Now let us suppose that pressure is not constant at every stage of compression, but changes in number of finite steps. The number of steps are the finite steps are there. In that case, work equal to summation of px into del v. Now similarly, if pressure is changes in infinite number of small steps, very small steps are there, then your volume equal to A into dl and force equal to pressure into area. So work done equal to P external into dV. So work equal to minus V initial into V final. If the initial V instead of V1, if put VI, instead of V2 to VF, then px into dv. So this formula also we require to be remembered for the work. Next we have next definition, we are taking free expansion. For free expansion, P external pressure will be 0, del U equal to Q plus W, that is the Q plus W is again minus P del V. Now if external pressure is 0, this external pressure is 0, 0 into del V is equal to 0, so that represents Q equal to U equal del U equal to QB. Now after that we'll start another thing, that is enthalpy, a new state function. Now most of the reaction in lab is done in under constant pressure. For that we have to write del U equal to QP minus P del V. Del U means fast law thermodynamics, del U equal to QP minus P del V. Now P cannot be 0 here, so that part is remain. Del U minus U2 minus U1 QP minus P of V2 minus V1, del V is V2 minus V1. So QP equal to U2 plus PV2 U1 minus PV1. So U2 plus PV2 minus sign common U1 plus PV1. Now this U1 plus PV1 or U1 plus U2 plus PV2 gives us another thermodynamical quantity called enthalpy. So what is enthalpy? Which is the sum of the internal energy plus pressure volume work. Enthalpy is nothing but sum of the internal energy plus pressure volume work. So del H equal to U plus PV. So H1 equal to U1 plus PV1, H2 equal to U2 plus PV2. So H2 minus H1, QP equal to H2 minus U1 equal to del H, or U2 plus PV2, U1 minus PV1, U2 minus U1, P common, V2 minus V1. So QP equal to del H, del U plus P del V. So this is the relation between del H and U. Thank you for today.